Welcome back to Ox Tools. I'm Tom. So tonight we got a couple little things that we're working on, kind of small projects. So this will be some stuff that gets rolled into Meatloaf, a Meatloaf episode. So we're working on the one of the last videos I shot that was on the lathe. I noticed with this longer arm, when I turn the spindle on, I get a big bump on the camera. I noticed it when I was editing the video. So this longer arm, the movement when the lathe fires up, the amplitude's higher, so it's kind of makes for crappy video. So what I'm doing is making a new mount that goes not on the lathe, but something near the lathe. Kind of like Double John over at Double Boost. He made a sky hook, I think he called it, which was a rail or something that he mounted his camera to. I can't really do that here because the ceilings are so high, and I don't have a lot of options for mounting. So I'm making a camera mount that's for lathe shots that'll allow me to move around and get those nice tight shots that you guys like on the lathe without the the disturbing images. So let's just put it that way. Anyway, so working on that, then I had a little idea for this is one of these Blake coax indicators, and I was talking to a guy, and he was talking about how he uses this to in the tailstock of the lathe to set his steady rest. And I hadn't ever seen that before. And there's several ways to align the tailstock, align the steady rest on the tailstock end and get that on the center line. There's some tricks for doing that. It's real important that it's lined up, or else the part can walk out of the chuck or do something kind of unplanned, we'll call it. Adam over at A-Bomb 79, he talks about this a little bit, and he's done a lot of big shaft work and tube work with these hydraulic cylinders that he rebuilds. So he kind of touched on some of those things. But I thought I'd make up a little test thing to mount this in the tailstock for sweeping the ends of things that are more difficult to center up. And then there's some viewer suggested ideas. A guy was asking about how do you accurately center up for an eccentric in the forejaw. So we'll probably touch on that a little bit. And also, kind of the last thing. I want to just thank John over at New York City CNC. He's got a YouTube channel over there, and if you guys haven't checked it out, go check it out and subscribe to his channel and throw some comments up there for him. He's got a little CNC machine shop, and he started from scratch about 7 years ago, and now he's doing some pretty cool stuff over there. So he's got some R&D things that he's working on, and some products and some Kickstart things and few other things. Anyway, John was very kind, and he did a very nice book review of my book. So I guess that's what I wanted to talk about also is, somebody asked, well, why doesn't he plug his book on his videos? And it's actually kind of a good question in that I kind of don't on purpose. But I guess I probably should, maybe, Anyway, the reason I don't do it, or haven't done it in the past, is it's kind of like, some martial arts master, right? He doesn't come into the room, the black belt, he doesn't come into the room and talk about how, badass he is and, how he's the master of the universe. No, these guys are very quiet and reserved and humble. Okay, and I guess that's kind of the attitude that I take, is that I want to be humble about this stuff, because some of the guys that I've worked with, they make me feel puny. Okay, I'm just a little, I'm pond scum compared to them. So I appreciate what they gave me, and I am humble about it. Now, on the flip side of that, indirectly, royalties from book sales, you know, they help support this operation. So, you know, a little free advertising for my publisher, what's the big deal, right? And it's not in your face, or I won't make it in your face, let's put it that way. You know, and, you know, I get a check a couple of times a year, and, you know, I buy machines with it. It's kind of like my Mad Money, and, you know, it supports this hobby workshop of mine. So anyway, I just want to thank John for putting that nice video review online, and I do appreciate it. Thanks very much, John. And for those of you that don't know, I did write a book, and that's the first book that I wrote. Okay, it's called Metalworking Sink or Swim. You can get it on Amazon. Industrial Press, which is the guys that do Machinery's Handbook, is my publisher, and you can buy it online directly from them. And anyway, this is the first one I did. And actually, it's coincidental that this recently, a second one came out. And this is a lot of the same material, some new material in this one. But the main part of this is it's been reorganized for smaller shops, do-it-yourselfers, that kind of stuff. And I noticed that they're selling it quite a bit cheaper than the other book. So anyway, that's the new one that came out, and there's the other one. And that is the end of the advertising portion of this show. So anyway, let's get cracking. Let's do some metal work and put some good content up there for you guys. So thanks for watching, and let's get going. Okay, so I got some pieces cut for the camera mount. So we're going to drill some holes, some pivot holes here, and so this is kind of a double jointed affair. And the thing that I'm going to connect to that's over near the lathe is a 4-inch pipe. I have that it's separate from the lathe, and I can kind of clamp to that and make a stable mount for the camera so I don't get that jitter when I'm filming on the lathe. So I got to do a little cutting on this. We're going to go change the bandsaw blade on the dual saw and trim these down. We'll weld those together. These are pivots and center pivot. And we'll put all that junk together and kind of get a try going here pretty quick. So, all right. So smack some holes through these tubes. All right. So that's clearance for the pivot bolt, which is about a 10 millimeter bolt, and we got them in both ends here, and then I'll show you how this thing all goes together. And then that's the center pivot. So let's do a little countersink on that. Well, I got it here. I'm lined up with the world. Yeah, it's basically a kind of a drill press job, but hey, you got a mill, use it, right? Okay, so we drilled these, drilled that, and we got the links drilled. Let's go do a kind of a setup on the welding table and see what we got. All right, we're just doing a little deep burn on the end. Little Scotch-Brite wheel here. Little hand check, make sure we're good. Okay. All right, let's do a little trial assembly here. Now these are just plain brass washers here. They're going to act like, kind of cheapskate thrust bearings here, just to give a nice sort of a bearing surface. So it's brass on steel as opposed to steel on steel. So that's the sandwich for the pivot end. Now let's go ahead and put a nut on that. Okay, and that's just a lock nut, and what I'll be able to do with that is vary the tension on this so I can get any kind of frictional qualities that I want here. Okay, so is this the one for that? Oh, this looks kind of long here. Oh no, that's okay. And this is just 1x1 1/8" wall, or roughly 3mm wall tubing. So 25mm square tubing by 3mm wall, approximately. Okay, so you're starting to get the idea here. So this can fold back in on itself. This can swivel. This can swivel. So I can get a pretty good range of motion here. This is at this end here. Like I said, I'm going to cut this down, and then that is it's going to clamp to this fire sprinkler riser pipe over there, and kind of like this. Let's see. Hopefully you can. Will that stay? Yeah, that'll stay. Let's see what that looks like on the camera there. Oh yeah, that's okay. You can see. Anyway, you're starting to get the idea. And then the camera will mount out here somewhere. I have a tilt and pan thing for the camera out at this end. The camera's on it right now. And then I can tip the camera down and swing it around this way by clamping it onto that. So that's the general plan. I'll flip that over so the seam is showing down. And then we'll make, I ordered a U-bolt basically to clamp this to the pipe just to make my life easier. It was $2.40 from McMaster. I was like, I don't think I want to make it for that. I mean, I could, but okay. So I'm cheap, but I'm practical too, right? Anyway, all right. So let's go cut these down on the bandsaw and weld some junk together here. All right. So we're gonna change the blade on the dual saw here. Right now I have I think it's a 6-tooth blade on there, and I got to cut that 1/4 inch, and it's just the wrong pitch for cutting 1/4 inch. It tends to catch, and anyway, it's a pain. So I'm going to switch it out for this one here, and I don't know. I don't think any of you guys have seen other than close-ups of this particular saw here. So this was a Craigslist deal here, and I recognized the handles on it in the picture. These kind of Art Deco handles here. It had no name on it or anything like that. They had a couple of shots, and I recognized these handles and the ones on the back there, which I don't know if you can see. Let me take a look here. Yeah, you can just barely see them, these little ship's wheels back here. Anyway, I recognized it as a dual, so I went out and looked at it, and they only wanted $250 for it, so guess what? I bought it. Anyway, it works fine. I didn't have to do much to it. Cleaned it up a little bit and made a new couple of little guard pieces, and it's running fine. Okay. So let's take now these blades are kind of long on this one. They're 17 feet long, or no, excuse me, 14 feet long, and so they can get a little unwieldy. But you can see it's pretty easy to change. Oops, I don't want to whack the camera here. Fold that up. This out of the way. Easy. Okay, blade's teeth are going the right way.
Thought I was gonna have to adjust the guides a little bit. Hey, I did pretty good that time. Oop. I always forget which way to go on this, you know. Every saw, each one's a little different. And I just kind of turn it by hand a little bit, and that gets it tracking properly. And then I tension it up a little more. Just give it a spin by hand. And I'm going to call that good. Oh, this is the guard I had to make for this thing, so I was missing that one. I don't know about you, but when I go to look real close, I don't like to get my head in there. I have enough trouble banging my bald head on everything in the shop. My wife says that she's going to get me a bicycle helmet to wear in the shop to keep me from dinging my noggin up. So, gotta keep it in good shape. Okay, so we're ready to do some cutting there. Down, one to go. Okay, so I got these kind of prepped. I knocked the mill scale off. This is this hot rolled angle here. So I knocked the mill scale off with a little grinder, and so I get a reasonably clean weld in there. I'm just kind of evening up one end. So I'll put a couple little welds along there and do a couple little welds on the other side. It's not going to need a ton of strength for this application. Three good tacks on that. Do kind of a sanity check here. Looks pretty good. What I want. So that'll sit against the pipe, and I can put it anywhere I want on the pipe, and then the U-bolts will lock it up to the pipe. So, if we do a little bit of welding on this, we're going to expect some distortion to happen. So it's actually pretty good right now. It was sitting on the tacks. So what I want to think about before I go crazy on go medieval on the welding there is. If it pulls, is there a favorable direction that it can pull in? And so, what am I thinking here? I think I would rather have it kind of poofed out a little bit as opposed to poofed in any. okay? So it's just a, just kind of a mental double check, because I don't really want to do a bunch of straightening, and it doesn't really matter very much if this is flat or super flat. So, but from a, looks crappy from 5 feet away kind of aspect, it would be better if it was curved this way, okay? So what I'm going to do is I'll start welding on this side here, and I'll do a little bit more welding on this side. We'll let it cool off, and then I'll do a little less welding on this side, so the net distortion would be this way, in the direction that I'm okay with. Anyway, it's just a kind of a mental exercise before you go welding up something like this. So let me get a little bit of welding on that. Then we'll knock the weld off of this side, and then we'll mount some of the other pieces there. Safe to do a little light pivot test here. Let me clamp that down. See what we got. Yep. folds up on itself there, and I can just move it up out of the way. Go ahead and give this. Okay, well, that's the general idea there. And then the camera will be mounted on that. Looking good, okay. All right, so these guys showed up from McMaster Car. These are the clamps that we're gonna use to secure this thing to this pipe over near the lathe. And so let's see. What I'm gonna do is now I could have bent one of these up and made it myself, right? These were $2.89 a piece, so I don't want to mess with them for that. So here's the idea: we're going to put these on here, 2 of them, and we'll weld this sheet metal part here to this, and then the loops will connect it to the pipe, and we're pretty much done. So let's get these welded on here, and we can get it up and kind of get a try with it on the machine. More weld on that, and then we'll get a try on it. Okay, so we get this on here. I put a little thing on the end that what the camera's on right now is on a little thing that clamps to a side window on a car for like a spotting scope. So that'll clamp on here if I want to use that. And then I have this little ball head mount right here that I can put. This is my spare camera here. Put that on there, like so, and then get that into the action area there, and then I can push it back, and I can move it around. There we go. That clears that. I made it so it just cleared that one. So I can push it back, pull it forward, get it up close, get it in line with the tailstock if I want, and it's all isolated from the lathe. So when I hit the spindle, let's just get a little spider web on it. When I hit the spindle, I don't get that, that diving board thing going on. So this is pretty rigid, and then I can push it out of the way and get it out of the way when I don't want to use it. Also, I suppose I didn't even think about this. I could put it this way too if I want to do a kind of a straight up, talking to the camera kind of a thing. So, all right, so I think I'll throw a little paint on that and start using it, or maybe I just start using it. You guys know how much I hate to paint things, right? So, we'll see it changing. I think I'm going to squirt it with a little paint just to make it rust up on me, and start using it, and we'll see how it goes. Okay, so we're getting ready to paint this here. I just want to talk about this stuff for just a split second here. This is called Steel It, and what it is polyurethane with 100% stainless steel metal flake pigment in it. So it's 316 type 316 stainless that's in suspension in the paint carrier. So when you spray this down, these particles of stainless steel just kind of overlap and lay on the material, and then the stuff cures. Anyway, it's pretty bomb-proof. McMaster Carr sells it, and I've had this can for a while. Hopefully it'll still spray. But we used to use this when I worked for a company that built bleach bottling equipment. Actually, it was Clorox. But anyway, we used to paint a lot of the small steel components with this that were kind of not in the direct line of the bleach splatter and whatnot, and the stuff would hold up for years. Anyway, I just kind of fell in love with it because it's a good paint, and it's about 12 or 15 bucks a can, but it's worth it for if you don't want to have to repaint anything. Anyway, that's what we're going to paint this with. So shortly you'll see it, and it'll be about that color right there of the can. Okay, so we got the arm mounted up now, the new camera arm, and I got my G11 on there. This is the camera I started shooting videos on YouTube with. But it doesn't have the resolution of the new one I'm using there. So anyway, that's kind of how it works. I got it on the ball head mount here, so I can move it around. And this one has a kind of an interesting feature. It's got this. Go ahead and turn it on there. It's got a little alternate screen there that I can use to kind of. I can see, I don't have to go around the back of the camera and look in the back, which is kind of an interesting deal here. So anyway, now this allows me to get up into the action there real close and get those nice shots that you guys like, close-ups, and then it's isolated from the machine. So looks like it's going to work. I'm going to try it out, and we got a little lathe job, excuse me, a little lathe job coming up here, and we'll try it out on that. And there's a button. Come on. We'll try it out on that, and then we'll see how that video looks. So, I wanted to show a couple of tools that I got off eBay recently. Surprising even to myself, I won an auction for a reasonable price. So I picked up a couple of things. It was two auctions. One was a set of 1, 2, 3 blocks, and we'll talk about those in a second. This wasn't part of it. That wasn't part of it. And then this little strange little surface gauge here, and the indicator wasn't part of this, just the surface gauge. So what these are, some tool maker had built these things years ago. And apparently he had some kind of accident in his home shop, or anyway he dropped dead basically in his home shop is how the story goes, and from the person with the auction. And the guy that had the stuff had bought it from the widow or whatever to help her out, and then he didn't need them anymore, so he was selling them off. Anyway, so he told this little story in the auction, and it caught my attention, and I like that kind of, well, I don't like the fact that he died, but I like those kinds of stories. Anyway, so let's talk about this little surface gauge to start with. This is kind of, we'll set these aside for a sec. So what this is, it's a little shorty here, but the thing that caught my attention is this front radius here. And what this is used for is checking squareness of, say, a block like this. So the way it works is you put that radius against there, and then let's see, maybe you can see the indicator there, and then you rotate this against the block. Now you calibrate this on something a known square, and now you can, and I think I bumped it anyway, so So what you're looking for is you're looking for the high spot, the return right there. And then what we do is just kind of tune that to get it on 0. And then, so you're looking for that, you're looking for that high spot. I don't have this adjusted right. But anyway, so that's what that, that's what that radius is about. Anyway, this guy had built this thing and it's kind of nice, right? So I got that. His name was Gary Morner. And we'll see that on these 1, 2, 3 blocks here, because he put his name in there in a very, very nice way. And so those were the way that was done. It's not engraved. This was plunge EDM. So this guy Gary made an electrode and set this up in the EDM machine, and he burned that in there, or burned out around the letters, basically, is what he did. So that's how that was done. And there's 2 of them. And anyway, you know, here's a tool maker, right? This guy's life is all about precision and you know, being dead nuts on everything. And I measured these. I calibrated my micrometer on a 1-inch gauge block and checked them, and these things are killer. They're spot on, as close as this 5 decimal place micrometer can read. Anyway, but what I like is it, you know, he cocked it at an angle there, you know, just to maybe to you know, it's probably a very exact angle is all I can say. But it, you know, this is not typical toolmaker behavior. Normally they'd put it exactly perpendicular to something or whatever, but he decided to throw it on there at an angle, which I thought was kind of cool. And so anyway, a moment of silence for Gary, and I hope he's working in the big tool room in the sky there. So okay, thanks Gary. Anyway, I just wanted to share this with you, and so I got the lot of these 3 things here with shipping. It was about $50. So there are some deals on eBay still. You just gotta you gotta try, and every once in a while you get lucky, and I consider myself lucky with these guys right here. All right, I just wanted to show these Squareness comparators here. This is the one I got on eBay that I showed earlier, and this is Gary Morner's. Anyway, the way it's set, you have a square reference here, and let me just turn this a little bit here, and you put it up against the square reference, and then you rotate it, and you're rotating it on this curved front edge here, and you're holding it in contact with the square, and you're watching the indicator, and you're looking for that high point. Okay, and that's where you calibrate 0. Okay, and I've already set this one, so I don't have to fart around with it. Okay, so that one's set at 0. Now I can compare a block here. I can put it up against the block, and then check the block, and that one's looking pretty good over that height. Okay, so anyway, that's how you use that, and you can change the height on this. Normally it's for kind of short blocky stuff like this. Now you see this other one in the background here, and I'm going to talk about that one in just a second. Anyway, that's how that's used, and that front curve. Okay, so now this one here, this one's a little different here. I built this one. This is my interpretation, and it's modeled after a Taft Pierce Squareness comparator, and it works the same way. And you rotate it, and you find that high point, and then I have this knob here that I can adjust, and you may be able to see that needle, I don't know. Anyway, so, but now this one can go up pretty high here, and so normally how this would be used is with a cylindrical square, and you calibrate it against a cylindrical square, and then you can check things up to the height of this, or the height of your cylindrical square at least, and see how, and this will give you a measurement over, so you can say, okay, I'm 1/1000ths or 2/1000ths or 5/1000ths out or 1/10 out over this height, so that gives you a dimension that you can actually cock your block to make it more square, if that's what you want to do. So you can do some very, very accurate work with these type of comparator gauges. This is pretty square here, this granite standard here, so that's kind of what I use right now. I have some cylindrical squares that I built that I'm waiting for a friend of mine to find some time to grind for me. I made 2 of them so he could have one too, and one of these days he'll get around to grinding them for me. And so anyway, that's 2 Squareness comparator gauges.